So, in support of the Halloween torture rack that I built, I said I'd do a little video basically on the code that goes inside and the prop controller. On this window, I've got the prop controller circuit, which is now hopefully filling it. And then on this side here, I've got the actual code. The code runs on a little Arduino Nano, which is a pretty small device. It's pretty useful, quite flexible what you can do. I'm pretty much going to run through the code more or less line by line. If you're not familiar with the code on Arduinos in this IDE, it's kind of like C, but it's got some object orientated stuff as well. It's pretty quick and easy to get going with, and I mean there's a lot of this code out there if you want more information. First off then, so here's the code, rack, single controller. I like to do a little pictorial of what the controller looks like and then put the pins that I'm using. So you see here I've got a couple for the audio player and some other ones referenced as well. And these numbers that you see here, D12 for example, that's GPIO pin 12. That can be then directly referenced in the code, so it makes it nice and easy to see, you know, what's going on. I'm going to start scrolling down. The first three lines, with these are where you include your libraries. Soft serial allows any two GPIO pins to use as a serial port, and then the DF Player Mini is basically using the latest version of the DF Player Mini, which has come up conveniently in here. So this is the header file. If you're not familiar with C, a header file is pretty much just constants and prototypes for functions. So these are all the functions you can call up in the actual code once you've instantiated it. And if you really want to know how they work, there's a C++ file underneath it which tells you exactly what those things are doing. For now we're just using it. Next line down, servo is a standard Arduino servo library. Allows you to talk to servos. Now I'm going to declare our pinouts that we use, so these should match the drawing up here. So you see that the one to turn on the lights on the prop are on D4, so I've called that light enable, and you can see some other numbers here. These actually relate to the circuit, so if we go over to the circuit, I'm actually using MOSFET number 3, which if I light up on this circuit diagram, goes to this MOSFET here, which controls this little plug on the board. So what else we got? PIR trigger pin, PIR mode pin, I'll talk about that a bit later. Servos on pin 9, the software serial port which connects to the audio player is on pins 12 and 13. And then the next two lines, this is where we declare our objects. So this is calling up an audio player which we've called my DF player, and we're also declaring a servo which is called rack servo. A couple of constants. There's a sound file, pardon me, just a pointer to which one you're playing, and then file count tells me that there are 3 audio tracks on the SD card and we're going to play different ones potentially. Next one down, some constants for storing the servo position. So these are real positions in degrees, 105 degree, 10 degree, and then I use a simple bit of maths here to basically calculate a half position and a quarter position. It actually is a 3/4 because the servo goes the opposite way round. Then some standard variables. One is which is called a state. The basic way the triggering works on it is it's something called a state machine. We'll go into that a bit later on. Now in Arduino code, the first thing that gets run when the thing boots up is a setup function. So we initialize a serial port. This is the one that allows us to print out debug to the console. Very useful for debugging your code and seeing where you are. Next one, my serial 9600, this is for the DF player. So this is initializing that soft serial port to talk to the player. We print out a couple of lines of commentary So these will pop out on the debug serial port. And then we call our first function where it tries to connect to the thing. This kicks off the function which basically allows the thing to feed back its status. So if you can't talk to it, it's going to return an error saying recheck the connection. If there's no SD card plugged in, it will return a function, return that saying there's no SD card. Otherwise, it's going to work just fine. And we say another printout, it's online, and this is where you actually set the volume. The volume of these little mini players can go from 0 to 30, and depending on your application, 25 is quite loud. We're still in the setup file. We're now going to declare the light enable to be an output, the trigger to be an input, the mode to be an input with a pull-up resistor, and we'll get to that one later. We also attach our servo. So this, we've declared the object, now we're actually attaching to it. So this now allows us to call functions in the servo. We're setting the state to be 0, and then we're printing out a little bit of debug stuff, rack, and then some parameters for the different positions of the servo, so that as the thing boots up, if you're looking at the console, you can see the parameters. Now there's another couple of random functions thrown in. One is called stretch, which effectively runs the servo one direction, and then another one called contract, which runs the servo the opposite direction. Now these get called in the main code when we are moving the skeleton up and down. So if you're familiar with C, you can slip over this. Basically the function is called stretch. Then there are 3 parameters provided called start, stop and speed. And then we simply have a for loop here which uses a standard integer variable, goes from start to stop and decrements, counts down, 1 equals minus counts down. And that's because in the way that the servo is done, the start position is actually a bigger number than the stop position usually. So it's going to count down from one to the other, and for each of these positions in the loop we write to the servo, and then we have a little bit of a delay as well. And the speed of the delay, or a time delay, is fed in from this speed variable, so you can call it when you call the function, so you can make it faster or slower as it goes round. The contract is exactly the same sort of sequence. This time it goes from start to stop, and it goes the other way, it increments instead. Now you could easily make one function which does both. You could have a mode pin, or you could detect that this is bigger than this and therefore you want to go backwards. But in the interest of keeping it simple, we're just going to have 2 separate functions. I like to keep my code super simple, it's super easy for people to understand then, hopefully. Now the next thing that runs in an Arduino application is a loop function, and this, like the sound of loop, goes over and over and over and over and runs forever basically. We have something here called a state machine. A state machines are really useful. Think of a traffic light system. If you ever want to think about a state machine, think that it sits in a stop line for a little while, it will move to an orange, and then it will move to a green, and then back to a stop line. If you think of it, it's sitting in a state each time. Now we already declared in our setup that it starts out in state 0, and this is where it's waiting to be triggered. So I spoke before about this PIR mode. I generally put a little jumper pin in the schematic on the PIR mode connection. So one of them is the actual PIR triggering the thing, and the other one is just set as a mode select. What you can do then is you can put a little jumper connector on the board if you want to make it move in a different selection. So if you've got no jumper fitted, you remember it had an input pull up, so it's going to be sitting high. So this is going to be the default. So in this mode we're using it as a trigger, and it's going to wait until the PIR triggers the thing before moving out of state. But if you want it to just loop over and over and over and ignore your PIR, which is useful for tests sometimes, then it will be in this one. You'll fit a jumper to pull that pin low, and in that case it's basically going to do something every 10 seconds, 10,000 milliseconds. 10,000 milliseconds is 10 seconds. And in both cases, they'll exit to state 1 when they're triggered. So assuming you've got you're using your pull-up, the PIR is going to trigger when it sees someone. Digital read PIR trigger is 1, the pin is going to go up, and you're going to jump straight into state 1. State 1 is our triggered state, so we print it out for debug. It's triggered. Light enable high, we turn our light on straight away, and then we start trying to play the audio. So the first thing we're going to do is play the sound file, which if you remember defaults to number 1, and then we're going to delay 100 milliseconds just to let the thing start. And then you can make this bit of it any way you want, whichever way you want to stretch it. So the way I'm working it is I'm stretching him up in one movement, and that's what this one does here. So it's going from a slack position to a 3/4 position, and I'm waiting 200 milliseconds between each and every step. So he inches his way up fairly slowly, and so raising him up to 3/4 of the maximum. I've then got a simple for loop, which is going to run 4 times from 0 to 3, and it's going to basically contract him back from 3/4 to half. It's going to wait, and then it's going to lift him from half back to 3/4. You see these are the same basic positions. So he's going to go, my little cursor is going to show, he's going to initially, in this one here, he's going to go up to 3/4, and then down here he's going to go from 3/4 to half, 3/4 to half, 3/4 to half, 3/4 to half, back to 3/4. So it makes it look like he's being jiggled up and down. We then wait 3 seconds, and then we do the final contraction where he goes from the 3/4 position right back to the bottom again. So again, pictorially, he started, if we say he started here, he went up to 3/4, and then in this next section down here, he went 3/4 down, 3/4 down, 4 times, and then finally goes right back to the bottom again. Once it's completed, we say it's done, and we jump down into a state 2, which is the turnaround state. Now this bit here, as I said, you could make this do anything you want. You could make it hammer up to the top and drop down. You could have it just inch up really, really, really slowly. It's entirely up to you. Mine is kind of synced loosely to the audio that's playing, but you know, if you've got different audio, you might want to do that differently. Case 2, turnaround state. This is where we've ended our state sequence, and we're going to go back to the position where it's not triggered anymore. So we turn the lights off, we set the servo to the lowest position, which it probably was done here anyways, but we're just being sure. We're going to wait 5 seconds just as a bit of a delay, and then we're jumping back to state 0 where it sits again. So it's going to sit in here, and then the next person who comes along who triggers it on the PIR, it's going to go through the whole sequence all over again. So the entire function of the program as to what it does when the PIR triggers or the servo is positioned is all within these few lines of code. And as said, you can do it many different ways. You could add any type of delay, you can put different types of stretches, you can flash the lights on and off, you could do what you want with it. So hopefully that gives a quick idea of what the prop controller is able to do with a basic piece of code just to stretch on the rack.